All right, so how did the moon form? Right, big question. Well, there's a few different theories. One theory is the co-formation theory. Basically, it's saying it formed at the same time from the same stuff. That's what it's saying. Um, but the Earth and the Moon are kind of too different to actually support this. And again, I'm covering it. Chapter 6 is not going to have a video. Anywho, the Earth has metal in the middle, and then rock, and then the crust. The Moon has rock, and then rock, and then rock. So if it formed at the same time out of the same stuff, where's the metal? So then the next theory is the capture theory. Basically, the moon formed somewhere out there and independently of the Earth altogether, and then somehow it got attracted to the Earth's gravity, and it just, there it is. Right? So because it's attracted to the Earth's gravity, you'd think it's actually pulling towards the Earth. Well, okay. However, the rocks that make up our mantle and crust are the same rocks that make up the moon. So why are the rocks exactly the same? They're too similar to be true. All right, so this brings us to the current theory. And as in astronomy, when in doubt, it was a collision. And sure enough, that's actually what they're saying. It's called the impact theory. The Earth was trying to cool. It probably already differentiated so that the metal was in the middle, the rocks were around it, and then it got smacked by a planet the size of Mars. And this planet caused all the rocks to get thrown out. So a good chunk of the crust and the mantle were tossed away, fragmented from this collision. If there were two iron cores, they were melded together. And then the rocks kind of just, re-disassociated. So you had the metal, the rocks, and it started to cool again. Well, all the fragmentation that went around started to just fly around the Earth because it was caught in its gravity, and eventually started to conglomerate together. Now, once it did that, that's where you got your moon. So this explains the similarities, right? The two planets kind of merged together with all the pieces flying off. So the pieces were part of the Earth. That explains why there was rocks and why there's no iron. The iron was too heavy to fly off, or the metal off, so it just had the rocks fly off and then form into the moon. It explains the similarities and the differences. And so that is the current theory, that there was just a giant... Alright, so all that happened about 4 billion years ago. And a little bit more than 4 billion years ago, actually. But at this point, the moon was newly formed, and then it just got hit by meteorite after meteorite after meteorite after meteorite. And so it started to get a lot of craters. So it had all these craters, but it didn't have any of the dark spots, any of the mares. And then 3 billion years ago, the mares formed, right? The mares being the basaltic flows. And then the basalt just suddenly stopped, and it kept getting hit and hit and hit, as it still is today, although not really big now. We're calling them micrometeorites because they're just kind of smoothing out the surface. But as you can see in the picture, you've got 4 billion years ago, 3 billion years ago, you can start to see the mares form, and then today, all those meteorites, micrometeorites, or other impacts smooth out the surface so you can't see the giant mares anymore. They're just little patches. And it's basically been the same, except maybe a little bit of smoothing from the micrometeorites.